Okay, now here's the second part. We're going to do the same problem again, at least using the same cone. But what we're going to do is we're going to figure out the rate at which the radius is increasing when the radius is 1.5 centimeters. So I think what you'll notice is that this is now going to be an R problem, not an H problem. So same cone, same radius, same height. Height equals 20. And so this time, same dv dt. This time we're trying to find the dr dt when the radius is 1.5 centimeters. And that's what we don't know. In this problem, we're using the same relationship, r over h equals 3 over 20. But you'll see in a little bit that we're going to rearrange that a little bit differently. So I have my drawing. Next thing I need to do is say the rates. Got that. And so check, check. And now the equation. Okay, this is kind of review now. 1/3 pi r squared times the height. And now we're going to change this into only an r problem. So in this case, what we're going to do is come back over here to this little thing that I've referred to as a key before. And now we're going to have h by itself by saying this is 20r over 3. And what this is going to do is it's going to let me plug it in this time into the h spot. And we're going to have an equation that looks like this. 1/3 pi r squared times, and now instead of h, I have 20r over 3. I'm going to simplify that. So 20 pi r cubed over 9 is now our equation. So I'm just going to check that off. And then the next thing is we're going to differentiate both sides of the equation with respect to time. Okay, and so let me just do that up here so I have a little more room. dv dt will be 3 times 20 times pi r squared over 9. I've left the 3 out there so that we can cancel. And then dr dt. And we're going to simplify this by saying that's the same as 1/3. And so now dv dt is going to be 20 pi r squared over 3 times dr dt. And like before, we're going to isolate dr dt so that it's 3 over 20 pi r squared dv dt. And now finally, let's evaluate this when r is 1.5. So 3 over 20 pi 1.5 squared, and dv dt is still 10. Okay, so I'm reaching for my calculator again. I've got 30 divided by 20 pi and 1.5 squared. And I get a dr dt evaluated when r is 1.5 centimeters is 0.212, and this again is centimeters per second. And so we've differentiated, and now finally we've solved. Ta-da!